Good evening. In the last videos, we covered very clearly about so how you can able to detect, okay, how you can able to detect cycles in so directed graph and undirected graph. Both we covered very clearly. So in today's session, this algorithm we are going to implement. What is this algorithm? Shortest path from source to all vertices. Suppose if you take any graph from source to vertex, sorry, source to destination or not a destination. So we are going to give some source from that source to all vertices. You have to find out shortest path, sir. First, I will take one example so that you can get clarity. Consider these are nothing but the nodes what I have. So these are nothing but the nodes what I have. First, I will explain the theory process. Then we can go with a programmatic approach. Okay. So there is a connection between this node to this node, and there is a connection between this node to this node, and there is a connection between these two nodes, and there is a connection between these two nodes. So there is a connection between these two nodes, and there is a connection between these two nodes, and here also there is a connection, and here also there is a connection. Sir, this one is undirected graph. If it is a sorry, directed graph, if it is an undirected graph, sir, we are going to get so many confusions, of course. So we are going to see that one also, but as of now I am explaining for directed graph. That means what? So this node to this node, there is a path. And from this node to this node, there is a path. And from this node to this node, there is a path. And from this vertex to this vertex, there is a path. Next and after that, so from this vertex to this vertex, there is a path. And from this vertex to this vertex, there is a path. And from here to, so here we have a path. I think everything is completed. Yes, let me fill this one also. Sir, the names of these nodes is nothing but it is 0th node, and this one is nothing but a first node. This one is nothing but sorry, not a second node. So this one will comes under second node. This one is a third node. This one is a fourth node. This one is fifth node. Sir, consider my source is nothing but 0. Sir, from here, if I want to reach 5, what is the shortest path? Okay, what is the shortest path? Okay, so that you have to find out. Sir, if I want to find out the shortest path, definitely there should be a weight, right? Sir, if I want to travel from 0 to 1, 2 units of time. If I want to travel from 1 to 3, 7 units of time. If I want to travel from 3 to 5, 1 unit. If I want to travel from 0 to 2, the weight is nothing but 4. 2 to 4, the weight is 3. 4 to 5, the weight is 5. Sir, 1 to 2, the weight is nothing but 1. Sir, 4 to 3, the weight is nothing but 2. Like this we have. Sir, now please observe my points. Consider I want to move from 0 to 5. I want to move from 0 to 5. There are n number of paths are there, right? Even in the yesterday or day before video, we have seen how to print all possibilities. Okay, how to print all possibilities we have seen. Sir, in that, one of the possibility, I can go from here to here, I can go from here to here, I can go from here to here. So to reach this, how much cost? Sir, 2 plus 7, 9, 9 plus 1, 10. Now, sir, any other path? We have so many paths are there. Have you observed here? 2 to 1 and 1 to 2, and from that 3, from that 3, so from that 5, like this we can travel. Sir, 2 plus 1, 3 plus 3, 6, 7, 8, 9. Have you observed which is the shortest path? Instead of going in this direction, we can go in this direction, so that the cost is going to be reduced. Maybe, sir, time, or we can say amount, or we can say fuel or anything. Okay, so shortest path is nothing but there are n number of possibilities will be there. From each node to each node, if I want to travel, what is the shortest path that we have to calculate? Okay, that is our agenda. Sir, on the top of every node, I am going to represent that shortest path, sir. Okay, I'm on top of the every node, I am going to represent the shortest path. Okay, of course, how it is going to work? For that, we have multiple algorithms are there One is nothing but, so Disjatra algorithm is one of that. Another one, we have another one is also there, Bellman-Ford algorithm. Like two algorithms are there. Of course, there are some problems with this Disjatra algorithm. It is not going to take any negative values. If any negative values is there, it won't work, sir. But how to implement this? I will take an example and I will show you. Theoretical part is different from practical approach. Can you please confirm, is the outline is clear for you people? Because if outline is clear, I will start explaining the theory processor. Can you please confirm everyone, is the concept is clear? Yes, please confirm everyone. Sir, only few responses I am getting. Right. Sir, to do this, what I am going to do here is, sir, first step, first step, sir, I will write weights of these nodes. Source to source, the weight is nothing but 0, sir. Source to source, the distance is nothing but 0. And from source to remaining nodes, if I want to move, I will take the distance as infinite. Okay, sir, from 0 to, if I want to travel to any node, that distance I'm going to keep it as infinite. Maximum value, because we are finding shortest value, that is least value we have to find out. That's why in your queue or in your data structure, if you hold maximum value, less than this, if any value is coming, that is nothing but the shortest path. Okay, now what we are going to do, sir, take the source vertex, which is nothing but 0. Consider adjacent nodes for this. Sir, which are adjacent for this node? We have one is there, at the same time 2 is there. For 0, which are adjacent? 1 and then 2. Sir, take 1. Take 1. What will be the shortest path from 0 to 1? Have you observed? To reach this node, what is the shortest distance? Have you observed? Sir, we have 0 plus the weight is nothing but 2. 0 plus weight is nothing but 2. Sir, what is the total value? 0 plus 2, 2. Is 2 is less than infinity or not? Yes. So update this weight, this particular distance as a 2. Okay, sir, next take another vertex, which is nothing but a 2. Sir, to move from this source to this 2, how much weight is there? 4. So 0 is the distance, 0 plus 4, 4. Is it less than infinite? Yes. So update this value with 4. That means to move to the node 1 or node 2, it requires 2 units and 4 units of time. Okay, sir, first vertex visited, completed. Next, take the next vertex, which is nothing but 1. Which are adjacent to this 1? Sir, we have 3 is adjacent. Oh, first we have to write 2 is adjacent and then 3 is adjacent. Sir, have you observed, to move from 1 to 2, sir, how much distance is required? 2 is nothing but the weight of this, the distance to reach to 1, and plus here the weight from this node to this node is nothing but the cost of this edge is nothing but 1. 2 plus 1, which is nothing but 3. Sir, is it less than 4? Yes. That means, sir, if you want to move from 0 to 2, it requires 4 unit. But if you move from 0 to 1 and from 1 to 2, it requires only 3. So shortest path is nothing but this one, but not this one. Okay, like this we have. Sir, 2 completed. Okay, 2 completed. Next, take the node called 3. Sir, to reach from 1 to 3, how much time is required? Have you observed? Sir, here the cost is nothing but 2. I mean, distance is nothing but 2. 2 plus 7, which is nothing but 9. Is it less than infinite? Yes. Update with 9. Update with 9. Yes, completed. Next, take the node 2. Sir, which are adjacent to 2? Sir, we have only one node, which is nothing but 4. Now take 4. Sir, what is the cost here? Sir, here this node, from here to here we are moving, right? This node cost is nothing but 3. That is nothing but a distance. and this particular weight is nothing but 3. 3 plus 3, which is nothing but 6. Is it less than infinite? Yes, update with that. Sir, fine, 4 is also completed. Next, take the node 3. Which are adjacent for 3? We have only 5 is there, right? Adjacent to 3. Sir, 9 plus 1. Okay. 9 plus 1. Is it correct? Is it 9? I think 2 adjacent is 4. After that, we have to visit 4 adjacents. Sir. Like this continuation process we have to do. Okay. Then only we will reach to the last node. So here 1 adjacent is nothing but first we have to start from 0. 0 adjacent is nothing but 1 and 2. While finishing this, 1 adjacent is nothing but 2 and 3. Okay. Next, for 2 adjacent node is nothing but 4. Whenever you are coming for 4, you have to visit 3 and then 5. Like that we have to take. While coming to 3, we have to visit 5. So here you can able to see I am traversing this 4, sir. Observe carefully. Sir, to move from 4 to 5, how much distance is required? Already 6 is there. Already 6 is there. 6 plus 5, which is nothing but 11. Is it less than infinite? So take it as 11. Okay. Sir, that's all completed. Next 3. Adjacent node is nothing but 5. Sir, if you visit 5, how much distance? Sir, here we have you observed this one also we have to visit, right? This one also we have to update. Already this edge got updated. This edge got updated. This edge got updated. This edge got updated. This edge updated. This edge is also updated. Now you have to complete this edge. Let us take this edge. 4 to 3. Sir, what is the distance here? 6. 6 plus 2, 8. Is it less than 9 or not? Yes. This one also completed. Next, this edge we have to complete. To move from 3 to 5, already weight is 8. Sir, 8 plus 1, which is nothing but 9. Is it less than 11 or not? Yes. Now, sir, if you want to move from 0 to 0, 0 units is required. To move from 0 to 1, so the distance is nothing but 2. For 2, what is the weight? 3. That is distance. Sir, for 3, what is the distance? 8. Sir, for 4, 6. Sir, for 5, it is nothing but 9. Sir, from source to all vertices, we got this distance, sir. Okay, shortest path. How much cost it is going to get? Have you observed? I explained, right? So to move from 0 to 5, 2 plus 7, 9, 9 plus 1, 10 is required. But if you move in this direction, so 2 plus 1, 3, 3 plus 3, 6, 6 plus 2, 8, 8 plus 1, 9, shortest path. Okay, like this we have. I think you people, at least outline, you people got a clear clarity. Sir. Can you please confirm? If you are clear with this, I will go to implementation. Clear? Right. Sir, we have to implement this process. How to implement? Sir, for this, we have to go for priority queues concept, but unfortunately, we have not completed that priority queues. Just outline structure I will provide, sir. Don't worry. Sir, I have a graph is there. Static class edge is there. Sir, in addition to this destination and cost, my requirement is I want to take source also. I want to take source also. And while creating edge, I will pass these 3 values. Okay. So this dot source is equal to source. Right. Edge class is okay. Then number of vertices, linked list of edge same. Graph I am creating. Yes. So all the vertices are with new empty things. Then I want to add a directed edge. Okay. Add a directed edge. I think here, so while creating, you have to pass a source also, right? First, we have to pass source, destination, and then cost. Then here also, we have to pass source, destination, cost. And here also source, destination. Yes, correct. Here we have to pass source, comma, destination, comma, 1. Okay. That's all. So we are adding one extra attribute called source. Okay. Then print graph. Sir, it is same like a normal graph only. Then I'm removing these things. And first we will draw that diagram, sir. Okay. So here, how many nodes are there? I think 6 nodes are there. New graph of 6. Sir, it is a directed values, right? That's why 0 to 1 cost is nothing but a 2. So 0 comma 2 weight is nothing but a 2. Then 0 to 2 weight is nothing but 4. Weight is nothing but 4. And 1 to 3 is there, 1 to 2 is there. 1 to 2 weight is nothing but 1. 1 to 2 cost is nothing but 1. So next 1 to 3 cost is nothing but 7. 1 to 3 cost is nothing but 7. Next G dot add a directed edge of from 2 4 is there. So okay, its cost is nothing but 3. 2 comma 4 comma 3. Next G dot add a directed edge of next from 3 to 5 is there, cost is nothing but 1. So 3 to 5 is there, cost is nothing but 1. Then 4 to 5 is there, cost is nothing but 5. So 4 to 5 is there, cost is nothing but 5. That's all right. Now let us print this graph. Sir, is it correct? 0 is connected to 2 and 2. Sorry, something is wrong. 0 to 1 is nothing but 2. Now see here, 0 is connected to 1 and 2. 0 is connected to 1 and 2. 1 is connected to 3 and 2. 1 is connected to 3 and 2. 3 and 2. Then 2 is connected to only 4. Okay. So 3 is connected to 5. 3 is connected to 5. So 4 is also connected to 5. Okay. And 4 is connected to 2 also, but that one is not there here. 4 is connected with 5 and 3. 4 is connected with 5. G dot add a directed edge of 4 is connected with 3 also. 4 is connected with 3 also. Weight is 2. Right? 4 is connected with 3 and 5. 4 is connected with 3 and 5. Okay, fine. So next 5 is connected with nothing. This is nothing but the graph what we have. For this, we have to calculate all pairs shortest path, sir. Can you please confirm up to this? Do you have any doubts? Please confirm. Just I added only the few functionalities which are required for every graph. Clear up to this? Please confirm. I request everyone to please respond. Right. Sir, next one, I am going to define one class, which is nothing but static class. I am defining static class. The class name is nothing but a pair. Pair. So which implements comparable interface. So which is going to hold pair values. Sir, what is this pair class? Sir, see, in the priority queue, based on the priorities it is going to add. Sir, which priority we are going to follow here? Have you observed? Sir, the default value, I mean the default distance for node 1 is nothing but infinite. Infinite will be there in our queue. Then if any node with the same content, I mean with the same vertex, If you are getting any other node, you have to store this one, you have to delete this one, and you have to store this one. And at the time of retrieving, sir, we have to get the minimum value, right? For that we need to go for a min heap, something like that. Anyway, that we will discuss in our priority queues. But here I am going to implement a priority queue. For that I am defining my own constraint, which is nothing but pair. In this pair class, I am going to define that vertex, and then I will take the path. Path in the sense distance. Okay, I will write a constructor. Okay, I will write a constructor which will take that vertex and then path, and it is going to assign this dot n is equal to n, and this dot path is equal to path, like this I stored. Next, and after that, this is our main agenda. Sir, I am going to override one special method called compare. Sir, how you are going to compare? So while storing into the priority queue, or while getting from the priority queue, which technique we have to follow? Okay, which technique we have to follow? Very simple. I am going to return, sir, current distance minus p2 dot path. What is p2 here? So whatever pair I am going to give, or let it be p, like this I am giving. So that means while comparing two distances based on the distance, so of that node, it is going to return. In this example, sir, first distance is infinite, second distance is 2. Sir, which is less, that one it is going to return. Sir, I want reverse longest path. If you want, then what we have to do? This, sorry, p dot path minus this dot path, like that we have to get. So then it is going to return longest path, sir. Then it is going to return longest path, like this we have. Okay, now let us see how you can able to work with this. My comparable class is completed. Sir, next we have to implement our main task. Sir, what is the main task here? Sir, I am taking static void. Okay, the algorithm name is nothing but disjatra, and it will take a graph g and then integer source. Sir, here what we have to do, you need to create a new array called distance. Distance is equal to new integer of how many vertices are there with those many values. Sir, now what we have to do, initially I am going to initialize all these values. I am going to initialize all these values except source. I is not equal to 0. I is not equal to source. Except source, remaining things I am going to assign integer dot max value. Sir, it will return the maximum value, something like infinite. I can't represent infinite, right? That's why. So after this we have to write our logic. Finally, so for integer I is equal to 0, I less than g dot v, I plus plus, you have to print that distance, sir. Okay, you have to print that distance. System dot out dot, so print of, so dist of I plus followed by space. Sir, first it will create a distance array with how many vertices, like this. It will create an array like this. By default, all these values are filled with zeros initially. Then we explicitly initialized with maximum value except source, because from source the distance is nothing but g. So remaining things we are going to initialize with maximum value. That means, you know very well, it is some different big value in the integer. So that's why I am assigning maximum value. Now we will write, sir, other than this value, if any less value is coming, that will be our shortest path. So that we are going to discuss here. Sir, except this logic, remaining things are clear for you people? Please confirm. Clear? Right. Sir, the next one, we have to implement the algorithm. Observe carefully. Sir, first step we completed, we have to write our main logic. Sir, every node is visited or not, we have to check. For that, I am creating a Boolean visited array, which is going to hold new Boolean of how many values? G dot v. Okay. Next, I will create one priority queue. Priority queue I am taking. Okay. Sir, which is going to hold the data in the form of pair objects. So PQ, priority queue, is equal to, so new priority queue, new priority queue of, like this I'm creating. Yes, one queue is also ready. Then first we have to add, sir, a new pair. A new pair I am adding with source. Your source is nothing but 0. And what is the default distance? Is nothing but 0. Yes, I added. Now what we have to do? Until your priority queue is not empty. Okay, until your priority queue is not empty. Sir, what operation? This is our main logic. Listen carefully. First, I want to remove the current node from queue, because these kind of operations we performed several times. We have to remove the current node. For example, consider if you take the previous graph. Okay, if you take this graph here, first we are going to add this node 0 comma its weight is nothing but 0. Like this I am going to add. Now I will remove this from the queue. Sir, from queue this value got removed. Now what we have to do? Sir, we are going to check which nodes are adjacent for this. How to get that values? Sir, here if not of visited of current dot n, if that node is not visited, if that node is not visited, sir, is the first node is visited? No, not visited. So then it is going to start. Okay, then it is going to start. Now what we have to do? Visited of that current node, I'm going to take it as a true. Okay, I'm going to take it as a true. Sir, why you are taking current dot n? Can't you take current? No. Current in our previous examples, it is integer. But here current is nothing but what? A list. A pair is there with n and then path. N is nothing but that vertex. Path is nothing but its distance. So that's why I'm taking that vertex and I'm making it as a true. Now you have to find out which nodes are adjacent for this. Okay. So edge temp is equal to, so g dot adjacent nodes dot, so get of current dot n, which nodes are adjacent for this. And you have to take for each edge present in that temp, one by one edge I am taking. Now my requirement is, I want to get three properties. What is the first property? What is its source? Next, sir, what is the next property? Destination. What is its destination? Then what is the third property? Weight. That is nothing but, in my terminology, it is cost. Have you observed, if you are taking any node, for example, if you have a node from 0 to 1, a node from 0 to 1, sir, consider this in the pair like this we have, and this one weight is nothing but consider 2. And by default, what is the weight? Infinite, right? So in this code, u is nothing but source and v is nothing but destination. What is the cost here? Sir, cost is nothing but something like 2. Now what you have to do? This is first vertex. Now what we have to do? Sir, if distance of u, okay, if distance of u plus weight is less than distance of v, then what we have to do? Sir, then two operations I am doing. First operation is nothing but I will update that distance, which is nothing but a distance of u plus weight. Next, I will add that into the priority queue. So add of, so new pair I am adding with so vertex v and then distance of v. Now observe carefully how it is going to be added. Okay, how it is going to be added. Have a look once. Yeah, thank you. Now see, sir, distance of u. Sir, what is the u? Here, this is nothing but u. What is its distance? 0, right? 0 plus, sir, what is the weight? What is the weight that we have? Weight is nothing but something like a cost. Sir, what is the weight? 2. Is it less than distance of v, which is nothing but infinite? Sir, is 2 is less than infinite? Yes, sir. It is less than infinite. Then two activities I am doing. What is that activity? distance of v, that is a distance of sir, what is that? 1. Okay, will be updated with distance of u, that is nothing but 0, plus this particular path cost, which is nothing but 2. Now it will be updated with 2. Sir, now that pair is there, right? So what is that pair? 1 comma 2. This value I am going to append to the queue. This value I am going to append to the queue. Okay, like this it updated. This is for first vertex. That is nothing but for e which are adjacent, that one. Suppose if you have any other adjacent, for example, consider we have 2 is there. Okay, sir, we have 2 is there. Sir, its cost is nothing but 4. Just for example purpose, I am telling. Now what will happen? It is adjacent to this, right? Then it is going to compare same thing. Sir, in this example, this is nothing but u, this is nothing but v, and v weight is nothing but what? Infinite, and this weight is nothing but cost is nothing but 4. How to calculate? Sir, distance of u, which is nothing but 0, plus weight is nothing but 4. Is it less than distance? Yes, 4 is less than infinite. Condition satisfied. Once if the condition is satisfied, distance of v, this value we have to update to 4. Then we are adding that into the pair. Sir, which value will be added? Sir, vertex is nothing but 2, its weight is nothing but 4. Like this we are going to get. Sir, this is a queue. So these are the values which they are in queue. Sir, it will be based on this weight. It will be based on this weight. Suppose if you are getting any weight with 1, it will come first, it will come next. Like that it will be there, sir. Okay, like that it will be there. Sir, now consider, sir, there is a connection between 2 to 1, or there is a connection between, sir, 1 to 2. 1 to 2. Sir, assume the cost is nothing but 1. Now what will happen? Observe carefully, sir. This will become u, and this will become v, and this will become weight, sir. Sir, now try to calculate. Sir, distance of u is nothing but 2, because we got this value. This gun popped, and this one will become e edge. Sir, e dot source. This is nothing but e dot source, right? Sir, which is value having 2. Sir, now distance is nothing but 2, plus this weight is nothing but 1. 2 plus 1, 3. Is it less than 4? Yes, condition true. Then what we have to do? This value I am going to update to 3. Okay, then you have to add that pair. Sir, vertex is nothing but 2, weight is nothing but 3. Which one will come first? This one will come first. Okay, from here we have to move to the next. That is the reason why we are taking pair class. Okay, sir, have you observed? Is it updated or not? Yes, now if you see, sir, is it best path or is it best path? This is the best path. Based on that only we got 3. So 2 plus 1, not this one. So like this, internally this priority queue is going to work. Sir, concept completed. Concept completed. Now let us execute this code. Really, whether we are getting the same output or not, we have to cross check. Sir, distance variable, distance, not a destination. Somewhere, yeah, here we have to take dist, distance, not a destination. And one more thing, I think we didn't call, right? So graph dot, what is a method name that I have taken? Disjatra. And we have to pass that graph. It will print automatically, right? Yes. Now let us compile the code. Sir, here method disjatra class can, because what is the problem? Here it is expecting source. We have to pass a source. Yeah. Let us compile and let us execute. Sir, have you observed 0 to 3869? Is it correct? 0 to 3869. Okay. Sir, the only key point is nothing but here only. The only key point is nothing but here only. Except that remaining things already we discussed, sir. Can you please confirm? Is the concept is clear for you people? Take multiple examples and practice. Then only you people will get clarity. Sir, clear up to this? Yes, please confirm. Right. Good, good. How we are getting these results means here you can see at the end I am printing the final distance. See here, one second. Sir, here we have node 0 is there, right? Sir, consider same example I am taking. Node 1 is there, node 2 is there, and this one is connected like this. So consider like this we have. Sir, its weight is nothing but a 2, its weight is nothing but a 1. Sir, now what I am taking here is, so consider this weight is nothing but, sir, I will give 1. Now we will see difference in the output. Sir, initially what we have done, we created one distance array. We created one distance array. In that distance array, total how many values we have? 3 values, because we have 3 nodes are there. So all these values are initialized with infinite except source. What is the source? 0. This one is initialized with 0. Okay. Now observe carefully how it is going to work with the different colors I am taking. Sir, my first step is nothing but I am going to take priority queue. I will add source and then 0. Sir, what is my source? 0. And what is the distance for that? 0. Sir, is my priority queue is empty? Yes, my priority queue is not empty. Then, sir, take the first element. This is nothing but I am going to remove from the PQ. Sir, this one will become what? Current. Current. Is the current node is visited n? Sir, visited array we will take with all the elements as a false. Sir, it is not yet visited, so make it as a visited. Then find adjacent nodes for this. For 0, which are adjacent? For 0, which are adjacent? Sir, 1 and then, sir, take 1. Take 1. Sir, then that one source is there, right? This one will become U. This one will become V. This one will become U. So this one will become V. And this is nothing but a cost. Cost in the sense I can take WT weights. Now observe distance of U. Distance of U is nothing but a 0. This one is 0 initially. This one is infinite. This one is also infinite. Sir, 0 E plus what is the weight? What is the cost to? Is it less than distance of V? Distance of V is nothing but infinite. Sir, yes, infinite. Sir, 2 is less than infinite. Yes, condition satisfied. I am doing 2 activities. What is the first activity? I am updating that in the distance array. What is that? D of V. V value is 1. That I am updating with 2, sir. That means to reach from here to here, we have 2. Sir, next what activity we are going to do? This one we are going to add. What is the value? Sir, 1 comma, its weight is nothing but 2. Then what is the another adjacent node? 2 is there. We have to look into that 2 also, right? For 2, which one is the source? Sir, for 2, U is nothing but 0 and V is nothing but this one. Now same operation. Sir, distance of U 0 plus distance is nothing but 1. Sir, 0 less than 1 is infinite. 1 is less than infinite. Yes, condition satisfied. Then distance of 2. Distance of 2 will become 1, sir. Right? Distance will be updated. Then I am adding that one. Sir, what is the node we have? 2, right? So 2 comma, what is the distance that we are going to get for 2? 1. This one is going to be added. Sir, perfect. Sir, now in my queue, how many nodes are there? 2 nodes. Now get the first node, delete this one. This one will become current. Now observe carefully for this node, sir, which one will become U? 1 is the source. That means this one will become U, and 1 for 1 which are adjacent nodes. Sir, we have only one node is there, which is nothing but 2. Okay, which is nothing but 2. Sir, this one will become P. Now this is nothing but a cost, that is nothing but weight. Now calculate distance of U, which is nothing but 2 plus weight is nothing but what? 1. Is it less than distance of V, which is nothing but 1? Sir, is 3 is less than 1? No, condition not satisfied. Then don't update, because to travel from this location to this location, 3 units of time is required. But to travel from this location to this location, 1, which is minimum 1. It is already there. Okay, like that it is going to work. Can you please confirm everyone clear up to this? Sir, at least now, please confirm. Yeah, good, Swapnil. Right. Sir, here there is one small problem is there, sir. What is that problem here is, sir, it won't work for negative indexes. It won't work for negative indexes. For example, if you have node 0 to, so node 1 and node 1 to node 2 is there means, sir, consider to move from this location to this location, sir, 2 units are required. Sir, to move from this location to this location, 2 units is required. To move from this location to this location, -1 is required. Can you please confirm? Assume this is nothing but a path 1 and this is nothing but a path 2. Can you please tell me, is the first path is minimum, second path is minimum? Can you please confirm? Yes, first path is minimum. But this algorithm is not going to work for a proper values it want to generate if the weights are negative. Okay, so that's why we need to go for next algorithm. We have to go for next algorithm, so that we are going to discuss in the tomorrow's class, which is nothing but Sir Bellman Ford. So these are nothing but authors. So he introduced one algorithm. Of course, in that also we have some disadvantages that we will discuss tomorrow. Okay, so one more algorithm is there, Bellman Ford algorithm. Tomorrow we will talk about this algorithm. Okay, and tomorrow I will give introduction to minimum cost spanning. Okay, minimum cost spanning tree introduction also I am going to give tomorrow. So Prim's algorithm is there. So some algorithms are there to solve this problem that we will discuss. Okay, sir, tomorrow class is there as usual at 7 o'clock. Maybe 7 to, I will take up to 9, sir. 2 hours a session I am going to take. So maximum, I will try to finish graph by tomorrow. Another 4 algorithms are there, but these algorithms are big algorithms. If it is taking time, I will continue on Sunday also. If it is completed, I will wind up on Saturday, and Sunday we will start a fresh topic. Okay. I think so. It won't be completed tomorrow because algorithm sizes are big. Okay. Anyway, we will see that tomorrow. Based on that plan, we will discuss. Okay. Right, sir. So thank you. We will meet for the continuation tomorrow. I will upload these running notes within few minutes. You can able to download. Thank you, sir. Sir, notes is not updated. Okay, fine. I will update it today. Okay. I will update it today. Yeah. Right. Thank you, sir. Yeah. Good night.